Hi there, the Math Dog here. In this video I'm going to look at function transformations of the form f of a times x and f of ax minus b. So let's get started. So this video I'll use two parent functions for demonstration purposes. The first one's going to be the quadratic function f of x equals x squared. So this may be redundant, but I'm going to go ahead and do the table here. So I'm going to use the points -3 to 3 going by 1, so f of -3 is going to be -3 squared. That's -3 times -3, so that's 9. So at the point -3, 9. So then we have the point -3, 9, which I already plotted actually, right up here. Then I have -2 quantity squared, which is -2 times -2 is 4, so we have the point -2, 4. Then we have the point -1. I'm using whole numbers here, or integers I should say. -1 quantity squared is -1 times 1 is 1, so that's -1, 1. And then f of 0 is 0 squared is 0, so we have 0, 0 at the origin. And actually the right side is going to be a mirror image of the left side, but I'll just go ahead and complete the table. So f of 1 is 1 squared, which is 1, so that's 1, 1. I forgot to put 0, 0 there, so there's 1, 1. Then 2 squared is 4. F of 2 is 2 squared, which is 2, 4. Like so, and then f of 3 is 3 squared, which is 9, so that's the point 3, 9. So we'll be using this function quite a bit in this video. The other function I'm used for demonstration purposes is f of x equals square root of x. So in this case f of 0 is the square root of 0, which is 0, so we have the point 0, 0. Notice that the domain here is all numbers greater than or equal to 0, because in the real number system you can't take the square root of a negative number. So then f of 1 is the square root of 1, which is 1, so we have the point 1, 1. 1 across, 1 up. Then we have square root of 4. Square root of 4 is 2, so we have the point 4, 2. And then square root of 9 is 3, so we have the point 9, 3. And again, you could connect those, but I'm going to leave those points unconnected right now. So we're going to use those two functions for a lot of our stuff here. Alright, so first topic here is, so how does like f of 2x compare to f of x? Well, 2 times f of x is going to stretch the function vertically this way to twice the height or amplitude that it was when it was just f of x. But now the 2x is inside the parentheses here, so let's just do a analysis here. So I'm going to use f of x equals x squared. So here, so when x is -3, we know f of -3 is 9, because -3 quantity squared is 9. Okay, but now to get 9 when I have f of 2x, notice I don't need 3 anymore. If I'm to take 2 here, I can put -1 point. Let's do a different color that we can see better. I can use -1.5, because 2 times -1.5 is -3. So what happens is I can bring this, I'm going to suck this point in halfway to the y-axis here. And that's like, it's like a magnet, and that's what all these things are going to get pulled. Everything we're going to do here is get pulled in pretty much to the y-axis. So this point's going to get pulled into here, half distance there. That's not a good color for plotting. Let's try something else. Let's use red. Okay, so then -2, f of -2 is 4. So over here, by the way, so this is going to be -1.5. And so the new points will be -1.5, 9. And I'm calling this function g of x equal to f of 2x. So we have the point -1.59. Now, f of -2 is 2 squared, which is 4. But now, so my input's -2, but since this is 2x, this just needs to be -1 now. This was again -1.5. So now x is -1. That's going to give me 4 when I have f of 2x. So I pull this point in half the distance to the y-axis here. So our new point is going to be right here. So it's getting sucked into half the distance that it was. Then f of -1. Okay, well 2 times -1/2 here is equal to -1. So the new point is going to be -1/2 1. So this gets, it's getting a little hard here, gets sucked into there. And then 0, 0, so this is going to be -1/2 here. 0, 0, 0 doesn't change anything because that's just going to be 2 times 0. So that point does not change. Notice it's on the y-axis. And then f of 1 is 1, so 1 squared is 1. So now I just need a half to get 1 because 2 times a half is 1. So this point's going to get pulled in. This is going to be 1/2 1. So we're right here. And then we have f of 2 is 4 because 2 squared is 4. But now I only need 2 when I have f of 2x because 2 times 2 makes, this should be 1 here, not 2. So 2 times 1 is 2, so we have now the point 1, 4. So this gets pulled in half the distance to the y-axis. And then we have f of 3 is 9. Well, this is 3, so this has 1.5 to make 3. So this new point's will be 1.59. So we have narrowed the graph by half. So everything gets pulled in half the distance to the y-axis here. And that's what f of 2x looks like. Now, let's demonstrate this on the Desmos Graphing Calculator, which is really useful here. So let's see, let's get that open. So let's graph the function, the original function we'll call f of x equals x squared. There's our nice parabola. So now let's do create a function g of x. So Desmos is really useful to get to understand how these function transformations work. So I'm going to call this f of 2x. And there you see in the blue is what I was talking about. So the graph gets sucked in to half the distance to the y-axis here. So the red was f of x equals x squared, and then this is f of 2x. Okay. Oops. Let's get back to our recording here. Okay, so let's move on. So how does f of 1/2 x compare to f of x? Again, we're going to use f of x equals x squared. Well, now, so again, we know this, -3 squared is 9. Well, to get -3 from 1/2, this is going to be -6. So this is now going to become, instead of -3 nines, it become -6 9. So this thing gets stretched away to twice the distance that it was. So this is going to be now, this is -3, so this is going to go to -6 here. So our point gets pushed away from the y-axis by twice what it was previously. Alright, so let's continue. So this is going to be -2 squared is 4. But to get -2, and I have a half here, I just use -4. So now the new points will be -4, 4. So we're out here. Okay, then -1 quantity squared is 1. But to get -1 here, I use -2, because -2 times a half is -1. So we now have -2, 1. So that puts us out here. Then 0 doesn't change again, so 0 squared is 0. So 1/2 of 0 is 0. So we have 0, 0 again. And that point doesn't move, it stays on the y-axis. So then we have f of 1 is 1, 1 squared is 1, so we have then half of 2 is 1, so this is going to be now 2, 1 over here. So we plot this point right here. So we're widening the graph to twice its width that it was originally. So then 2 squared is 4, so I need 1/2 of 4 to get 2, so this is going to be 4, 4. Which is here. And then we have 3 squared is 9, so I 1/2 of 9. Well, actually, so this is, the input is 3, so this is going to be 1/2 of 6 is 3, so we now have the point 6, 9 instead of 3, 9. And there is our graph. I could connect the points. I'm not going to do that, but I will show this on Desmos again. Let's bring that up. We already got it somewhere here. There it is. Okay, so we've got f of x equals x squared. So by the way, this is the graphing calculator on Desmos. At the menu at the top, you look for graphing calculators, and then you find a graphing calculator. You can do this. So f of x, so I'm going to have g of x, I'm sorry, equals f of 1/2 x. I'm going to put the 1/2 in parentheses here. I didn't mean to do it that way. I want to put it out here. There we go. Then that's going to be x. And you see the blue graph, how it is twice the width. So this was 2. This goes out to 4. This was -2 goes out to 4. This was, let's do an obvious point here. So this point here, that was 4. So this goes out to 8, etc. So you can see again that it is widened by twice its original width. Alright, so let's continue. So how does f of negative x compare to f of x? And now we're going to use the square root function. So let's complete the table. Square root of, well, we got the table here. Square root of 0 is 0, square root of 1 is 1, square root of 4 is 2, square root of 9 is 9. But I want f of negative x. So to get 0, this is just going to be 0 again. So that's going to be 0. So the point 0, 0 doesn't change on the graph. Now, to get 1, if I have a negative here, this is going to be -1. So my new input's -1. So this would be -1, 1 on the graph, which puts me right here. Okay, then I have square root of 4 is 2, but to get 4 here times -1, this has to be -4. So this is going to be -4, 2. And what you can see is we're getting a reflection across the x-axis here. I'm sorry, the y-axis here. This is a mirror image. So here's our reflection line. And then we have 9. So square root of 9 is 3. But to get 9, and I have -1 here, this is going to be -9, so this is going to be -9, 3. Which puts us right here. And you can see that these graphs are mirror images of each other along the y-axis, which is the equation x equals 0, but this is the y-axis here. Alright, so on Desmos, let's go to that again. Demonstrate that. So if I have y equals, or f of x equals sqrt is their square root function of x. Then I go f of, I'm going to go g of x, call it g of x equals f of negative x. You see that we get the mirror image. The blue graph is the mirror image of the red graph and vice versa. All right. So now, given the graph of f of x, plot the graph of f of 3x. So this would be, you could probably actually do this on Desmos, but you'd have to create like 1, 2, 3, 4 piecewise functions, which would be a little challenging. So from what we know, from what we've just done, we should know that these points are all going to get sucked in to this y-axis here, and since it's f of 3x, this is going to bring, so all the points are going to be taken to 1/3 their previous distance from the y-axis. So this is 3, 1/3 of 3 is 1, so this point will get, I'm going to use purple now, is going to be right here. Okay, because 1/3 of 3 is 1. 1/3 of 6 is 2. 1/3 of 0 is 0, so that doesn't change. This is 1. This is 1 away. 1/3 1 is 1/3. That's going to be in there. Barely can fit it in there. And then 1/3 of 9 is 3. So now our new graph will look something like this. You can see the range does not change here. The minimum, the max values in the y direction do not change, but the x values are going to get shrunk to 1/3 of what they were. So originally the range was from -6 to 9. Now it's from -3 to 2, or to 3, I'm sorry. Okay, so this one I'm not graphing on Desmos, but we're pulling everything into 1/3 its previous distance from the y-axis. Okay, so these next, I'm going to do these sample problems. I'm going to use Desmos to do this because I think it is visually the best way to see what's actually going on here. So these are functions of the form f of ax minus b. So basically, I'm starting with f of x equals x minus 1 quantity squared. That's going to shift the function 1 unit to the right. Then I'm going to take g of x is f of x minus 1, which is then going to shift that function 1 more unit to the right. Now this is what's interesting here. So f of 2x minus 1, what it's going to do is it's going to shift the original function f of x 1 to the right, but then it's going to pull it in half the distance to the y-axis. And j of x, being f of 4x minus 1, will again shift the original function f of x 1 to the right, but from where it's at, it will pull it back into 1/4 of its distance from the I should be saying the y-axis. I think I just said the x-axis. And then the last one, the best way to understand that is to graph this one, and what it's going to do is it's going to reflect the entire function over the y-axis and put it on the other side of the y-axis. So let's demonstrate these now using Desmos. So first I'm going to type in the function f of x equals quantity x minus 1 quantity squared, which I've done a video on horizontal translation, so it took the parent function f of x equals x squared and it shifted it 1 to the right. So now I'm going to create a second function, g of x, which takes this function, f, and shifts it 1 unit to the right. So now the blue function is the red function shifted 1 unit to the right. Now we're going to do f of 2x minus 1. I will call this function h of x. it's kind of interesting what it does, at least in my opinion. So this is going to be f of 2x minus 1. Okay, so h of x equals f of 2x minus 1. This is the green graph. Well, where is it coming from? Well, let's go back through this. So f of x equals x minus 1 y squared, so it's the red graph shifted 1 to the right. G of x represents f of x minus 1, which is the blue graph, okay? So what happened there? The red graph was every point on the red graph shifted 1 right. Now, h of x is f of 2x minus 1, so it's taking the red graph and it's shifting it to the right 1 to the blue graph, but then it's taking every point on the blue graph and it's taking half the distance back to the y-axis. So for example, this is 2 goes to 1. This is 4, this goes to 2. Okay, and then this is at 0, it doesn't change. Alright, so if we then look at some points here, notice this blue graph is pulled in half the distance to the y-axis in terms of the green graph. The green graph is half the distance to the y-axis that the blue graph is, and you can see this. So that's what's going on here. So f of 2x minus 1 is shifting the function f of x 1 right, but then it's pulling it back into half the distance from the y-axis. Alright, so now let's do f of x equals 4x minus 1, or we'll call it a new function, we'll call it k of x equals f of 4x minus 1. Okay, so where's this one coming from? This is now the purple graph. So what's happening here is it's taking the red graph, shifting it 1 right to the blue graph here. Okay, that's the shift of 1, but then every point on the blue graph now is reduced to 1/4 of what it was. So it's getting pulled into 1/4 of what it was towards the y-axis. So for example, this is a value of 4 here, but the purple graph has a value of 1. Okay, so this is a value of 2. 1/4 of 2 is 1/2, which is what's going on here. So this function shifts f 1 unit right, and then that graph, it pulls in, every point gets pulled in to 1/4 of its distance from the y-axis that it originally was. And last, we're going to do one more here. We're going to call this j of x. And we're going to take f of negative 2x minus 1. Alright, so I'm going to get rid of some of these now because it's getting a little cluttered. Perhaps I'll get rid of it. But if you remember the green graph, I guess I can leave it on there. The green graph is here. Notice what happens when I put the negative 2 out here. The way I want to understand this is, okay, so let's plot f of 2x minus 1 first. That's here. Once we get that plotted, then we just take the mirror image of it over the y-axis, which is what's going on. The black graph is the mirror image of the right graph. The black graph is the mirror image of the green graph reflected over the y-axis, and that's how this works. So let's go back now to our sheet here. So let's write out what we did here. So this is going to be shift x squared 1 right. Okay, this shifts f 1 right. So it's actually shifting x squared 2 units right. Now, what does this do? So this shifts f1 right. And then compresses it, or compresses it with respect to the x-axis. Or I guess we should probably say takes half the distance, to the y-axis. So it's going to get a little cluttered here if I try to write this. So I'm just going to say the next one. So this shifts it 1 right, and then takes 1/4 the distance to the y-axis. And then 5, let's take in terms of this graph. It's going to take this graph and it's going to reflect it. So it reflects f of 2x minus 1 over the y-axis. All right. So now, given the graph of x squared, let's try to graph f of 2x minus 6. So what we're going to do here is we're going to shift f 6 units right, and then take half the distance to the y-axis. Half distance to the y-axis. So let's use red for starters. So this point here is going to get moved 6 right, but then it's going to get sucked back to here because we're taking half the distance back. Every one of these points, so this point here gets moved 1, 2, 3, 4, 5, 6, gets sucked half back to the y-axis. That's to be 3.5. This point here, 2, gets moved to 8. So half of 8 then is 4. It gets put right here. This is 3, gets moved 6 to 9. Half of 9 is 4.5. It gets moved right here. Okay. Now, this is 1, 2, 3, 4, 5. 1. This is from -1. Plus 6 makes 5, so then this gets pulled to 2.5 right here. Okay, this is 2. -2 plus 6 is 4. Half of 4 is 2. That puts us right here. This is -3 plus 6 makes 3. Half of 3 is 1.5. So our new graph is in red here, and let's look at that on Desmos. Alright, so let's do f of x. Again, our original function is f of x equals x squared here. So now we're going to do g of x equals f of 2x minus 6. And there you go. That's what we had. So again, what's happening again? So we're shifting each point 6 right, and we're taking half the distance back. So here again, this is 2. 2 goes out to 8, but half the distance from 8 is 4. So there's the new point, and so forth. Okay. Okay, so next, given that the function f of x equals the square root of x, plot the graph of f of negative x minus 6. So what I'm going to do here is I'm first going to shift the square root function 6 units right. And then this is telling me that I'm going to flip it over the y-axis. So not all these points are going to fit on the grid that I have here, but I'm going to take every point and move it 6 over. Then I'm going to take those points and flip them over the x-axis. Let's use a different color here. Did I say x-axis? X-axis, I meant the y-axis. That's not. Let's use a color. Let's just use black here. So we got that, and then this is 6 units away. This is going to be 7 units away. This is going to be 10 units away. And so the graph would go like this. And let's show that on Desmos. Okay, so I've got my original function called f of x equals square root of x. Okay, then I'm going to, our final function is going to be f of x equals sqrt, or square root of negative x minus 6. And there you go. So you could see then, again, if I shrunk this, you could see the graph. So again, what I did on paper was I moved everything 6 units to the right, then I flipped it over to get the blue graph. Okay, in this next example, I'm just going to use quote pencil and paper unquote. Not going to try it on Desmos. I probably could do it in Desmos, but you'd have to break it up into line segments in a piecewise, as a piecewise function, and I'm just not, don't think that's worth it here. So what I'm going to do is this function f of 2x minus 1, the first thing I'm going to do is I'm going to shift f 1 unit to the right because of that minus 1. And then this 2 is going to cause every point of this shifted function to get pulled in 1/2 the distance to the y-axis. So 2, move each point. I'll say new point. 1/2 the distance to the x-axis, y-axis, sorry, the vertical axis. So let's choose a color. I'll use purple here. So first I am going to move everything 1 unit to the right. Now I move each point 1/2 the distance to the y-axis, so there, that's 1/2 the distance right there. This is 5, so this goes to 2.5. This is 1, so it goes to 1/2. This is 2, so it goes to right there, and then this is 9, so it goes to 4.5. And if we connect the points, we'll get our new graph. So we have this. So what happens is the domain, the range doesn't change because the max value and min value are the same, but the domain gets shrunk in 1/2 of what it originally was. Alright, so what I'm going to do is I'm going to copy this graph and take it over to the next page, because the next one I'm going to take f of negative 2x minus 1. So I'm going to start from my ending point, this orange colored graph. So I'm just going to copy it and move it to the next page. Okay, so now we're going to do f of negative 2x minus 1. And I'm not going to be, not going to be redundant here, so I'm just going to move this into place. I'll keep it that size actually. So what we're going to do here is, let's imagine we're starting with the red f of x again. So our first step is 1 again. Move or shift F 1 unit to the right. Which is what the purple points are. Then we moved each point 1/2 the distance. Moved each new point 1/2 the distance to the y-axis. Okay, now what's different here is we have this negative sign, so what we're going to do is we're going to reflect each point over the y-axis. Reflect each new point. So let's choose a color here. So we use blue. So orange now goes to here. This is what, 3.5 away, the way I've drawn it here. So that goes to 3.5 here. This is 1 away here, goes to 1 away here. This is half away here, goes half away here, and then this is 4.5, goes to 1, 2, 3, 4, 4.5 here. So now we connect our points and we get our final graph. So the blue is the reflection of the orange with respect to the y-axis. This concludes the video. So if you found this video informative and you liked it, please give it a thumbs up and consider subscribing to my YouTube channel, The Math Dog. You may share the content of this video with others. Thank you and have a good day.